In this video, we're going to talk about what we call rate in, rate out problems or applications of integration. Okay, so kind of adding on to our applications of integrations that we've been talking about for the last couple days. So our standard is I2. We're on page 207. The target is students will apply the fundamental theorem of calculus using an initial value and a rate of change to determine a total in an applied context. So remember, anytime we integrate something, we're getting a total or a net change of whatever we're integrating. Okay, so we've been talking about that and how we set up initial value problems and things like that. So I'm going to use a model to kind of demonstrate how these problems kind of work. With these problems, we start with this idea of an initial value. Let me get some pens here. Okay, so starting value in a problem, a beginning value. Okay, and this is already a total. Okay, so a total of 5 inches of rain or a total of 10,000 deer. So giving a total of something. Okay, then we have this idea of what we call a rate in. Let me get a different color. So we have something or that's being added to this total at a particular rate of change, so a derivative. And then we have this idea of something being taken away from this initial value or this total, and we call that the rate out. So a rate in is something that's being added into, rate out is something that's being subtracted from. Okay, so our rate out is causing our initial value to become smaller. Our rate in is going to be added in. Okay. It's making our initial value get bigger. So it's increasing this initial value where our rate out is decreasing it. So we've been either dealing with one or the other. We haven't been dealing with both at the same time. And that's kind of what we're going to talk about today, how we set it up to deal with both of those at the exact same time. So like I said, we call these rate in, rate out problems. Okay. So if you'll see, just like in my model, in order to actually talk about a total value, remember we integrate a rate, so we're going to integrate our rate in. And this is something we're adding to our initial value. And then we're going to be subtracting out our rate out. Okay. Okay. So when we arrange this, that's what creates that equation that's at the top. Biggest thing to remember is we're going to have a start time and an end time for our rate in, and our start time and an end time for our rate out. And these two times are not necessarily the same time interval. So be very careful on, we always want to kind of keep them separate, so just in case those time intervals are in fact different. So we're going to see examples where our time intervals are the same, and then examples where our time intervals are different in this video. So let's kind of start with our first example. It says for t in between 0 and 18, oil enters a tank at a rate of E of t gallons per hour. So gallons per hour implies that E of t is a rate of change. It also says rate of change. And because it's entering the tank, we call this the rate in. So whatever oil is in the tank, we're adding in oil into that tank. So it's going into that total. And then it says at the same time, oil leaves the tank at a rate of L of t gallons per hour. Same units, rate of change, and because we're leaving, we call this L of t the rate out problem, or the rate out equation. Okay, where t is measured in hours past midnight. At midnight, there are 2,000 gallons of oil in the tank. And what that's giving us is at t equals 0, at our start time, they're telling us that we have 2,000 gallons in our tank. So we call that the initial amount, initial value. Very similar to the problems we've been dealing with. Okay, so it says using each component of O, explain what the function O of t equals to 2,000 plus integral from 0 to t, e of x minus L of x dx. Okay, so you'll notice that in the sentences, the first sentence, it says E of t and L of t. And then when we're creating a generic integral, and that's exactly what we're doing here, because it's going from 0 to some time t that we don't know. Okay, when we're creating that integral, we often replace the original t's with x's. Okay, so that's kind of a way to distinguish the two functions. Okay, because we know when we integrate, we're going to plug in our limits, so our x's are going to become t's as part of the fundamental theorem of calculus. So it's kind of just like a placeholder to distinguish between a generic integral and the overall functions themselves. So we'll actually do that in a problem later on in this video. Okay, so it represents in the context of the problem. Okay, so like I said, we've kind of already distinguished what it is. So we have this idea of this 2000 being our initial value. Okay. Our e to the x is our rate in, and our L of x is our rate out. Okay, so we have this idea of 2,000 gallons. We're adding in a total and we're subtracting out a total of what's coming out. So overall, O of t, so let me get a different color. We'll go plain. So O of t represents the total. Remember, keyword for integration is to use the word total. Okay, total, and we're talking about oil in the tank. In gallons at a time t, or at time, actually let's put at time t. Oh, I don't even know how to write today. Okay, and what this means is like for any time that we want to figure out how much oil is in the tank, we could plug that in for t, evaluate this integral, and find out exactly how much oil is in the tank at, let's say, t equals 3 hours, or t equals 5 hours, or t equals 7 hours. Now we just plug it in, and we can figure out all those values with the exact same equation by replacing that top limit. Because it's just a very generic integration or integral of how we kind of set up these rate in, rate out problems. Okay, so let's actually do one where we set it up, we solve it. If you don't have a calculator, I'm going to give you the values, but all the values that I found, I found utilizing technology. So kind of keep that in mind as we go. Okay, let's see if I can get this to move up. So a lot of times we're talking about problems that are multi-part problems where you have an A and a B and you're using all the information very much like the FRQs we've been dealing with in class. So this example says, after the AP calculus exams, students post memes at a rate of M of t equal to, and then it gives us an equation for M of t, for 0 to 24 hours, where M is measured in students per hour, T is measured in hours after the AP exam ends. So up to 24 hours after the AP exam ends. So they do monitor social media to kind of look at to see what kids are posting about the AP exam, and if anything kind of seems off, you can kind of get in trouble for those things. So just kind of be careful with that. Because remember, people are kind of still taking the test as students come out. Okay, so if we're posting, that means we're adding into the social media. So we're going to consider this because it's a positive rate. We're adding in. We're going to consider this to be the rate in. Okay, the rate in of students. So students are increasing. So we're going to call this our rate in. How many students have posted memes? Okay, so after 12 hours, College Board begins canceling scores of student posting memes at a rate of C of t equal to. So we have memes being posted, we have scores being canceled. Okay, For T in between 12 and 24, where C is measured in students per hours and T is measured in hours, says let S of T be the number of students who have posted memes but have not yet had their scores canceled. So if we think about M of T represents every student has posted the scores. C of T represents the number of students who have had them canceled, and then we're looking for the difference between those two. So I'm going to define S of T just so that we have an equation to go with. So S of T, off to the side, is going to be equal to, well, at T equals 0, we don't have an initial value. Nothing has been done, so our initial value is 0. So I don't need an initial value here. But we have the integral from 0 to T of m of x, and I'm just replacing it because we're just creating a very generic equation. Okay, and then we're going to subtract out the integral. And this is one where the end time and start time are different for both situations. So our start time for scores being canceled is 12 to T of C of x. Okay, it's kind of just very generic, quickly write an equation that represents, we have the memes being posted, so we're adding in, and then we're subtracting out anybody who's had their score canceled to get an overall number of students who've posted but have not had canceled scores. Okay, so that's kind of just that generic. So just setting it up, I don't even know what the questions are asking, but we're kind of just reading the problem, analyzing the problem, things like that. Okay, so A says, after 24 hours, how many students have posted memes? Round your answer to the nearest whole number. So right now we're just looking at the posting of the memes, which just has to do with M of T. So if I want to know the number of students who have posted memes, remember at T equals 0, there are 0 students. So our start time is 0, and it says after 24 hours, so our end time is 24, of M of T dt. M of T represents the rate at which they're posting. Integrate that, and we'll get the total that have posted. So equals, and then if we plug this into the calculator, we get 3,529 students. Okay, so within 24 hours of the exam ending, 3,529 students have posted. Okay, so B says find S of 24 to the nearest whole number. Show the computations that lead to your answer. Okay. So S of 24, we've defined what S is. So now we have a T value to plug into our function for S. So S of 24 equals, everywhere there's a T, I'm plugging in 24. And because now we have a value for T, we can leave this as M of T dt minus, and then of course, our integral for C starts at 12 and it's going to go to 24. And of course, we can go back to being T because it's not a generic function. It is an exact function for the problem we're dealing with. Okay, so if we do that, we actually get 0. I think it actually equates to 0.1628. Okay, so we get 0 students. Okay. So kind of talk about what the meaning of this is in the context of the problem, of course. So I would say something like after 24 hours, there are 0 students who have posted memes but have not had their scores canceled. So within a 24-hour period, everybody that posted a meme had their scores canceled. And that is actually a real possibility. I'm not saying that they will cancel scores if you post a meme. That's not what I'm saying. But it is like you have to really watch what you post because College Board actually monitors social media during the tests, after the tests, and continues to kind of watch it for until all tests have been actually graded. So they do monitor those things, so kind of be careful. Okay, I just want to make sure I have everything that I'm talking about. Okay, so um, posted memes but have not had their scores canceled. I know that's very long, but that's our noun. That's the subject of the problem. Our number would be 0. Okay. Our units would be students, and timestamp would be 24 hours. So we have the N, the U, and the T. Okay. Let's kind of talk about another problem. Okay. So this example says the rate at which people enter the Indianapolis Zoo on a given day is modeled by the function E, defined by E of t equals to 23 natural log, for t in between 0 and 24. Okay, so people who are entering the zoo, which means we have a rate in. So here's our rate in. Okay. The rate at which people leave the zoo on the same day is modeled by the function L, modeled by L of t. And people are leaving the zoo, which means we have a rate out. In for people entering, out for people leaving. Both E of t are measured in people per hour, and the time is measured in hours after 8 a.m. These functions are valid for 0 to 12, the hours during which the zoo is open. At time t equals 0, there are no people in the zoo. So that last sentence tells us that our initial value is 0. Okay, so let's kind of write that as a point. So 0, 0, very much like we were doing the last couple of days. So both have the same time interval. Okay. So the first question says, how many people have entered the zoo by 12 p.m., which is t equals 4? So now we only care about the people entering the zoo. Because we're looking for a total, remember that's an indication that we're going to integrate. So if I want to get the total amount of people, I would integrate, get a different color, integrate from 0 to 4. And I'm talking about the people entering, so I'm talking about my rate in, which is E of t dt. And then when I calculate that, again, all this work I've done in a calculator, I get 203 people. So by 4, 203 people have entered the zoo. Okay, so maybe we write that down. Okay, so people entering the zoo, 203 people, 12 p.m., all 3 parts are there. Okay. So B says 20% of those people who leave the zoo are selected at random to receive a special discount ticket for a return trip to the zoo. How many people have received a discounted ticket by 5 p.m.? So now we're talking only about people who are leaving the zoo. So we're only really going to be dealing with our rate out problem. So if I want to integrate, get the total amount of people, I'm going to integrate the rate at which they're leaving the zoo. Okay, from 0, time starts at 0 to 9. And it talks about 20%. So really this is 0.2. So 20% of these amount of people will get that discounted ticket. So if we calculate what that is, that gives us 79 people because we don't have partial people here. So I think the exact was 79.1803. Okay, so the first one talks about just entering, the second one talks about just leaving, and now let's look at what C is doing. So it says let n of t equal the integral from 0 to t e to the x minus L of x dx. So they're giving us again that generic equation that represents for all times t, for t in between 0 and 12. It says find the value of n of 10 and explain the meaning of n of 10 in the context of the problem. So let's start there. So if we're plugging in n of 10, or we're plugging in 10 for our t value. So 0 to 10. You can keep this as e to the x. You can keep it as e to the t. It's not going to really matter at this point. So I'll keep it as e to the x this time. Minus L of x dx. And then, of course, I'm using a calculator to calculate this. We get 274 people. Okay, so now it says explain what this means in the context of the problem. Okay, because this is the rate going in minus the rate going out, we have people entering, we have people leaving. So at t equals 10, the total number of people that are actually in the zoo is 274. So I would say something like n of 10 represents the number of people in the zoo at t equals 10 hours after opening. Okay. We could say this number is 274 people. I think with the math and that sentence right there, we kind of cover and explain the meaning, because they didn't really talk about like the answer. They just talk about the meaning of the problem. Okay. And then the second question says, find n prime of 10 and explain the meaning of n prime of 10 in the context of the problem. So now we're talking about n prime, which means we're talking about the derivative of n of t. Okay. So I'm just going to move this up a little bit. So if we think about n prime, to get n prime of 10, I need to first get n prime of t, and that was a very ugly n. So n prime of t means what I'm doing is I'm taking the derivative with respect to x of the integral from 0 to t e to the x minus L of x dx. And if remember from the second fundamental theorem of calculus, that said that any time that our derivative and our integral came together, they were inverse operations. They were going to cancel each other out. And all we had to do was plug that back in for every x in the problem, which means this derivative is just simply the rate at which we're entering minus the rate at which we're leaving. So n prime is the rate, so we get back to e to the x and L of x, which are rates itself. Okay, so if we actually take that and plug in 10 now, so e to the 10 minus L of 10, I did all of these calculations in the calculator. I wind up getting negative 6.2278 people per hour. Okay. Then it says, describe the meaning in the context of the problem. Because we've just taken the derivative, now we're talking about a rate of change. So, n prime of 10 represents, we're describing a rate of change. Okay, the rate at which the population is changing. And because that rate is negative, we can say that the population is decreasing. Okay. So if we get a question that asks, is something increasing or decreasing, and we're dealing with this idea of rate in, rate out, this is kind of the process for figuring it out. Look at the derivative, see the sign, and tell us whether it's increasing or decreasing. Okay, so right behind us is some practice. So it takes a little while to kind of get used to the problems and the setup and pulling all the information out. The next thing you should work on is the next page, which I believe is 209. If you have any questions, come in and see me.